Okay, so we have a problem. As you see the circuit here, we are going to find out the most simplified version of the circuit by using the Boolean algebra rules. So we have three inputs, X, Y, and Z. And our goal is to find out what is the output F based on the combination of X and Y and Z. So we have three gates here. You should find out the values of the gates at their output. So we have three gates, so we are going to start by finding out the output of each by going through from left to right. So the first gate that we have is XOR. This is an XOR, and because of this there is a NOT after that, and we have AND here. So let's start with this point. So what is the output here? So definitely it is XOR of X and Y, which in terms of AND and OR, it equals to X Y bar or Y prime plus X bar Y. You can call it C for simplicity. And as you see, it goes to two places. It will be an input to both of these gates. So I have C here, and I also have C here, which is this value. Now, let's calculate the output at this location. So what is the output here? So based on what we see here, it is C X or Z not. This is the XOR, and because of this we have not. We have prime of this value. From the equivalent we learned. So we learned there is an equivalent of XOR. If I have A and B and it's XOR of A and B, it equals to A prime B plus B prime A. So the same thing I can do here. So it equals to C prime Z plus CZ prime. Okay? Now, what I'm going to do is going to calculate NOT of it, because this is the value in the bracket. And we remember that we have to negate it. At this point, we need to use the De Morgan's rule. So it means I should calculate, it's better to make use of a bar on top of this expression. So a bar on top of C bar Z or CZ bar. How it can do the job. So you see, it's an OR of two elements, and if you apply bar on each of these, it will become C bar Z bar. The addition or becomes and CZ bar becomes CZ bar on top of that. Prime Z bar equals to Z bar, Z prime equals to Z bar equals to NOT of Z. So whenever I use bar or prime, those are coming with the same concept, NOT of something. Now to simplify, I need to apply the Morgan rule more. Remember, there is an AND between each of these two elements. So what is AND of these two elements? Again, I need to use the Morgan rule. The Morgan rule will be applied to each of them one by one. So C bar bar, C prime bar equals to C. And AND becomes OR, and Z becomes Z bar. Then I have AND here, and I apply the Morgan rule again at this location. C becomes C bar or C prime, and becomes OR, and Z bar becomes Z. So this becomes the simplified version of it. Now distribute. So this equals to C bar or C prime plus CZ plus Z bar C bar plus Z bar Z. We know A bar equals to 0 because A is either 0 or 1. These are bits. If A is 0, it becomes 0 times 1 equals to 0. If A equals to 1, it becomes 1 times 0 equals to 0. Either case, A bar, any variable times its complement becomes 0. By understanding this, we can simplify more. So we are going to get rid of these two. So whatever remain is CZ plus C bar Z bar. So the output here is CZ plus C bar Z bar. Now I have AND of these two elements. One input, another input to this AND. So what should I do? AND of C and CZ plus C bar Z bar. And it equals to CZ plus CC bar Z bar. If you multiply or AND an element with itself for any number of times, it equals to that element. Because again, A is either 0 or A equals to 1. If A is 0, this is multiplication of all zeros, which is at the end 0. If A equals to 1, this is multiplication of 1s. So then I have 1. So you can get rid of multiple multiplication of C and just write one of them there, CZ. And for the other one, we already learned multiplication of a variable to its complement equal to 0. So the second part becomes 0. So simply what remains is CZ. So F equals to CZ. But we had C here. Now you are able to plug into the equation what the C stands for, and then you get to the final value. So C equals to xy bar plus x bar y, as we know it from here, and we have Z here. So if you multiply, the most simplest version becomes x y bar z plus x bar y z, and that is the final answer for output of this circuit.